Dirty Scrap Podcast.
Welcome back again to Dirty Scrap, the aluminum podcast. This is the podcast where we dive into the sustainability or sustainable and efficient production practices on the aluminum recycling industry. I'm your host, Julio Quintero, and just let me get it and make myself more comfortable. Okay, here it is. There it is. Okay, here we go. So today I want to talk about, and this is very exciting to me because I've been talking about these, let's say, approaches for a long time. I want to make an episode, not today, but I will do it, about, it's going to be like a summary about every interview that I did in the podcast and all the journey that I've been going through since I started in 2020. So I want to talk to you today about some exciting innovation in the aluminum melting technology. As everyone knows, and I want to say thank you to all the people that been supported the episode that I've been like, the episode I did like a week ago or something, talking about and doing the analysis about the roadmap of the aluminum new industry, the roadmap that is like the call to action for the sustainable aluminum new practices here in the US. That is the roadmap that the Aluminum Association brought to us, that I think is amazing. But saying that, going in the same direction, I want to talk about different type of technologies and innovation that we will see in the next 1, 2, or 3 years. And I think it's going to be even faster. The next year, we will see some of those technologies going out there and making a really good progress. And what I want to talk to you today is about, and I have my script here because I am changing a little bit the way that I am approaching to the podcast when I'm doing the episodes myself. Why? Because I want to improve the way my communication with you guys, because I am very smart in Spanish, but I am not so smart in English. So I'm same guy, but you know, when you are trying to communicate in a different language, it's not that easy. Anyway, saying that, I want to talk about plasma technology into the melting furnace. It's very interesting because we are seeing out there a lot of different approaches, and we will talk about different approaches right now. So we will talk about regen burners. We will talk about electrical furnace or electric furnaces. We will talk about hydrogen. But at the end, we will talk about plasma burners, because plasma is the fourth state of the matter, but it's like an entity, it's like an ionized gas. It's very interesting, this approach. So let's dig in. So the first thing I want to give you as an information is, obviously aluminum is a critical material for the future production, right? So we are seeing the aluminum more and more, becoming more and more important in the last 10 years. And United States is trying to play a big role here in the industry, not just for the internal market, but also, you know, to the global level. And saying that, I want to talk in another podcast, in another episode, about the EVs and how China is getting more stronger while we are doing a lot of different type of approaches on the EVs. But I mean, it's another topic. We will get into that in a new episode. But China is going to win, just for you to have an idea. But let's move in the direction that we want to move in this episode. So aluminum is very important because it's very light, it's recyclable. You can recycle aluminum as much as you want, and it's light, so you can put it into the new, let's say, technologies that we are seeing out there, because it's giving this to these technologies more, let's say, it is more reliable for that technologies to have aluminum, because it's light, it's strong, you can recycle as much as you want. So aluminum is great, but the problem with the aluminum that we have today is CO2 emission. So as I said, everyone is talking about, oh, I want to build a new plant, but this new plant is going to be almost net zero, because they are comparing these plants with the secondary plants with the primary ones. And that, I think, again, I think that is a mistake. So getting into this approach, what I want to do is to compare different technologies that we are using in the secondary aluminum industry. And I don't want to compare anything related to secondary and the primary, because it's not fair. Why? Because if we compare the secondary industry with the primary industry, we are not getting into the point that we really want to get. That is, let's improve the practices and the technology of our industry, apples to apples. So, as I said, aluminum is a critical material for the future product, and the carbon footprint here is still a challenge, right? So, we used to use gas fire burners, traditional burners, that is, can be a recuperative burner, or can be a regen burner. So let's talk about the regen burners for a while, for a second. But before going in that direction, we need to understand that when you have oxygen present and you are burning gas, you will create CO2, period. It doesn't matter if it's a super high technology regen burner, that is the burner that we are using in our furnaces, because they are very efficient, is the truth, and they are really good technology. But even though we have a really good technology, still they are creating a lot of CO2 emissions. So let me read you something. Why? Because traditional gas-fired melting processes release sustainable CO2 emissions. So we will have on the secondary industry at least 120 kilograms of CO2 per 1 ton of aluminum that we are melting. That means that we are more or less having 220, 230, 250 pounds for every ton of aluminum we are melting. Obviously, if you compare these against the primary, the difference is huge. You will create like 16 tons of CO2 emissions per 1 ton of aluminum that you are processing on the primary side. That's why we need to understand very well that the secondary industry can evolve and improve just taking in account what is happening in the secondary industry, right? So on these type of burners, what you will create is 250 pounds of CO2 for each ton of aluminum that you are melting, but not just that. Also, you need, when you are using regen burners, you will create at least 30% more because you are burning oxygen, right? So this is something that we need to understand. Yes, it's a great technology. Definitely, it is. But also we need to understand why a lot of different people is going in different directions, like electrical furnaces or hydrogen or plasma. So saying that, I think the technology that we are using right now is very good. That is gas-fired burners, but definitely we need to go and see or turn our head and see another option. So let's say that to address this, let's say zero carbon footprint, we are heading to different type of alternatives that have been, let's say, explode, right? So when you do some research, you want to go and say, oh, okay, this is the technology. So let's talk about electrical approach. So from the electrical point of view, we have different approach. One is electrical resistance. That is heating elements that can be heating elements that we will submerge heating elements, electrical resistance, induction coils. The problem with that technology is size and scale up. So you cannot scale up this technology to the size that the industry wants to go. Why? It's pretty simple to understand. First of all, let's talk about electrical resistance. The electrical resistant is obviously can be like a carbon neutral, but the problem is the power density we will have in those, let's say, accessories is very low. So you can use those accessories as we are using it in the die casting industry, that is small furnaces for heating up or to hold the material before the casting process. But if you want to go and just ramp up the scale that we have right now to tons and tons of aluminum that we want to melt, it's not going to be possible. Now, a lot of people will say, oh, okay, what if we go on the induction furnace side? And yes, induction furnaces are a really nice tool. They are amazing. The efficiency related to the energy consumption is the higher one. So if you compare this with rotary furnaces, reverb furnaces, stack melted, definitely the energy efficiency on the induction furnaces is the higher. Now, saying that, the problem is scaling up these type of furnaces. They are not very flexible. Why? Because you need, let's say, to understand cleaning process, maintenance process, scrap size and geometry, scrap cleaning approaches. So it's a furnace that you definitely cannot use, for example, for, I don't know, I mean, you can use it, but it's going to be a waste of time. You cannot use for, I don't know, engine block or transmissions. Or, you know, the induction furnace is a very efficient furnace for light aluminum material that is very clean. So you can have a lot of aluminum recoveries out of it. But then if you want to scale it up, it's going to be very complicated, very, very complicated, because the maintenance and flexibility is super hard. So you will have a lot of issues in that direction. Even though it's a, let's say, an approach that the United States is looking at it, it's a good approach if you have aluminum chips, shredded aluminum profiles, light aluminum material or light aluminum scrap that is completely clean, and you have low volumes. I will say, I don't know, maximum 15 tons per hour capacity, melting capacity. You're okay. You're okay. Now, hydrogen. Hydrogen is a very, 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 let's say, new material or combustion material that we can use in the industry, and so many people is getting in that direction. It's nice, but the problem is, I will say, infrastructure and feasibility is limited. The feasibility is limited, and the infrastructure is limited. And I think it's going to be very expensive. Now, saying that, and I am not consider myself, I have a lot of knowledge, I've been in the industry for a while, I have a lot of experience, I know a lot of people that is teaching me a lot of different things, but I am not an expert or 100% on the process. But what I understand is if you are using hydrogen, you can create metallurgical problems because you can affect the metallurgical properties of the material. Remember that when you are on a casting process, you use filtering boxes, but also you will use the gassing lances or the gassing rotary, how do you call it, shaft. Definitely you will use some kind of degassing system to degas your material. And when we are talking about degassing, we are talking about not just about oxygen, we are talking about hydrogen content. So if we are using hydrogen as a combustion source, definitely we need to understand how this approach will impact the metallurgical properties. So again, just for a quick recap, regen burners are really good. They will use the energy of the other burner and in the furnace to heat up the refractory balls that they have site, but they will burn burning oxygen. You will create between, let's say around, as an average, 250 pounds of CO2 per each aluminum ton that you are melting, plus, let's say, 30% more that you can add on CO2 emissions because you're burning oxygen. Then we have electrical approach. Electrical resistance, not that good because you cannot scale up because the power density they have. And then you have induction furnaces. Induction furnaces are a really good tool, very efficient, but not too flexible and really, really complicated from the maintenance point of view. Now we have oxygen is amazing. Sorry, not oxygen, hydrogen. Hydrogen is an amazing approach, but the problem is going to be very expensive. I am sure it's going to be very expensive. And I am sure that feasibility limitations from the infrastructure point of view is going to be very, very challenging. And I think this can be also something that we need to address, that is metallurgical properties impact. So saying that, let's dig into the plasma burner solution. What is the problem with the plasma right now, and why these companies that are out there doing the research on the plasma let's say approach for melting capacities, melting approaches, melting processes on the aluminum side are taking the risk to understand and to research more and more the approach. The problem is, how do you create plasma? Plasma is an ionized gas. So you need an atmosphere with certain type of gas that will allow you to create plasma out of it. So you will have a cathode and an anode, and then you make an arc between them to ionize the gas. So the gas is going to be heat up as like this, and the temperature is going to rise very fast and it's going to high temperature. What is the issue? The issue is if you have an anode and a cathode working like that, for a melting process, you will destroy those materials very fast. So from the maintenance and the spare parts point of view, is going to be not sustainable, period. You will change those anodes and those cathodes very often. So that's the idea, that a lot of different people is getting into a different direction. So what they are thinking right now, and this is a very nice approach that I haven't think on it since the last time I was talking about plasma, because plasma for me is a complicated stage of the matter that you need to understand how to create, how to manage, but also how not to decrease the useful life of the accessories that are creating the plasma, in this case, anodes and cathodes. So let's dig into the new situation. Some companies out there are creating a really nice plasma burn. How? It's very interesting. What they are doing is they are using an induction coil to create the plasma, and then they will avoid the direct contact between the critical component and the high temperature. This is an amazing approach because you are taking out all that is the bad thing that you use to create plasma, and you are just bringing the plasma state with an induction coil. So what we are seeing here is induction coil applications on the plasma creation. Then saying that, this is the most important thing, talking about the secondary aluminum. Let's talk about, and just for a little bit, let's talk about CO2 and aluminum recoveries, because we need to focus in those two directions. Everyone is talking about, oh yeah, we need to reduce the CO2 emissions. We need to go to net zero, and we need to be eco-friendly. And yes, that's fine, and I am totally agree. But you need to focus as well on, let's say, 100% no dross generation. Why? Because okay, let's say that you are using certain type of technology that allow you to reduce your CO2 emissions, but in the process, you are creating a lot of draws. So you need to deal with that draws. What is the way to deal with the draws or salt cake that is even worse because you are using salt or fluxes to help the melting, let's say, system to melt faster, the aluminum. So you create salt cake and you need to have some disposal, let's say, landfills or areas, right? So when you are going in that direction and just focusing on the CO2 emissions to low down those, you need to understand also that you are forgetting about byproduct dross generation. And when you forget about that and you create dross, you will create more process downstream. That means that you will use more electricity, more energy, more burners, more people, more landfills, more whatever. So actually you are not getting into the point that you are more efficient, but also you are creating a source problem or a problem source. So the idea is to focus in those two directions. CO2 emissions, great. Technology, scrap, cleaning, and in this case, plasma burner. That is 100% CO2 free, is easy to integrate into the existing furnaces, so you don't need to replace the. And this is why I am talking about the dross. Dross generation comes out of the oxygen interaction between the aluminum and the atmosphere, or the oxygen that is present in the atmosphere, right? So you create oxide. Once you create oxides, you will have two different or several different options. Or you take out on your skimming process the dross, you let it rest, put it into rotary furnace, you create CO2, you take aluminum out of there, and then you will have more byproduct, or you will have to add a metal reclamator system so you can separate the oxide from the aluminum, and then you melt the aluminum, and then with the oxides, landfills or whatever, right? But you understand that the oxygen is the problem that is creating the dross, but also you understand that you need to go upstream and use the lacquering processes, segregation processes, separation, shredding machines, whatever it is, and then match the right technology with the type of scrap that you want to melt. You will reduce aluminum byproducts and you will reduce CO2 emissions. But with this new technology that we are seeing right now, we will have flexible atmosphere control. That means that you will not need oxygen into your burner system to create the power that you need to melt the aluminum. Crazy, huh? Let me explain this. Plasma is an entity, because they consider plasma an entity. Plasma is an entity that you can use in several different approaches, like thin films applications, plasma sputtering, and plasma deposition, and so many different approaches. In this case, or in those cases, you always are using a vacuum system. So you control the atmosphere and you extract all the oxygen out of the atmosphere. You can do the same with this technology in your furnace. That means that you will not burn oxygen, you will create zero CO2 emissions, and you will drop down, I don't know if it's to zero, but you will drop down dramatically the dross generation, because you have no oxides coming out of the aluminum, because you don't have the chemical interaction between the hot aluminum and the oxygen presence into the atmosphere. How cool is that? So again, this approach is, to me, super interesting, because you are seeing a technology that is coming very strong with a different approach that you can avoid spare parts replacement very often, but also you can create a vacuum atmosphere to reduce your dross generation, so you will increase your aluminum recovery. So you will have high melting efficiency processes, you will have high aluminum recoveries, you will have, or maybe you will not have to deal with byproducts, so you don't need to add more equipment, so your investment is going to be in the direction of just growing your company. How cool is that? I know in 2025 we will see some of the big players here in the US using this technology. I understand, as far as I know, a lot of companies, big ones, are using a lot of these plasma new burners on a lab scale, and they are doing very well. So what is coming? Plasma is a technology that everyone wants to check. And if someone out there is using plasma or is dealing with plasma research and want to be here in the Dirty Scrap Aluminum podcast and enlighten us a little bit more about this technology, you're more than welcome, guys. That's the purpose of this platform. So electricity is coming, definitely, but it's hard to scale up. Regen burners are good, definitely, but they will create some CO2 emissions as well. Hydrogen, I don't know, maybe very expensive, maybe the infrastructure is not there, maybe we will not use hydrogen at all. Plasma looks like it's coming with, I will say, three big advantage: 100% CO2 free, easy integration on the existing equipment, atmosphere control for no dross generation. Thanks to all of you guys that are seeing these episodes. Please help me to share this information with the people that is out there. I am Julio Quintero. I am your host. This is Dirty Scrap, the Aluminum Podcast. See you later. Bye, guys.
Dirty Scrap Podcast.